Yeah, comes on everyone. Let's start off. Last time we have started with the introduction of equipotential surface. Hope everyone has gone through the notes. Great. So these are the things which we discussed. So on equipotential surface, the work done in moving a charge is zero. The electric field is always perpendicular, and two surfaces cannot intersect because there will be two directions of the field. Let's go ahead with one question. Let's try this. So 2 point charges are there, Q1 and Q2 occupy fixed positions at every point on the curve. So this curve, he's saying this is an equipotential curve. And he said this equipotential curve, matlab, no matter where you stand on this curve, the potential is 900. That's it. You only have this information. Using this information, he is asking you to find the distance between the charges. And the interesting part, just now we made a statement that two surfaces cannot cross, and here I'm saying they are crossing. So what's the catch? Oh, didn't I just contradict my statement that two surfaces cannot cross? So you have to go back to the reason there again. What was the problem when they started crossing each other? The argument you gave, Advait, your cam is blank, I can't see you. Others do keep your cams on. So the argument was this. At the point of intersection, you will have two directions of field. So you cannot have two directions at the same time. And that was the problem, isn't it? But if I say, no, you are definitely crossing, how can a vector have two different directions? 3D. That's possible if it's a zero vector, isn't it? So that's the argument there. This point must be the null point. Clear? So that is the catch there. So if you figured it out, then it is easy to solve. So at the point of intersection, there are two possible directions of field, which is not possible. This is possible only if it is a zero vector. That is, that point is a null point. If the field is zero vector. Yeah, once you figure that out, then it goes pretty straightforward. So let this distance be R1. Let this distance be R2. So if that is a null point, then the field will be KQ1 by R1 square, KQ2 by R2 square. That's your equation 1. And the potential KQ1 by R1 plus KQ2 by R2 must be equal to 900. That is given. This is equation 2. If you solve these two from here, you can find R1 and R2. Two equations, two unknowns. You will get R1 and R2 from here, and that will give you the distance between them. All clear with this? Not a tough question, but yeah, you need to understand, like, if you're crossing, because the whole question looks as if there is, insufficient information there. So the idea was that figuring out the null point will give you the additional equation. All clear with this? Let's see one more. So we have concentric shells. Which are equipotential. So this shell ka potential is 60 volt and the radius is 10 centimeter. This shell ka potential is 30 volt, radius is 20 centimeter. This shell ka potential is 20 volt and the radius is 30 centimeter. So these are all equipotential cells. So each shell is equipotential. Be careful. All the shells are not equipotential. Each shell is equipotential. Matlab on that entire shell, the potential is same. So the inner shell ka potential is 60 volt, radius is 10. The second shell is 30, third shell is 20, and so on. So we drew few of the equipotential cells. So this is a equipotential surfaces. Right. So using this information, find the electric field in the region. You have to tell me the magnitude and the direction. If I give you another type. So these planes are equipotential. Parallel planes. Let's say this is 40 volt, 30 volt, 20 volt, 10 volt. This distance is 10 centimeter, comma 0. This distance is 20 centimeter, comma 0. This is 30 centimeter, comma 0, and so on. And this angle is 30 degrees, 30 degrees, 30 degrees, 30 degrees. So these are equipotential planes. So they have given some equipotential surface in the region. So looking at these surfaces, you have to tell me what is the magnitude of the field and what is the direction of the field. So there are one or two ways to do this. So one thing, right? The most easiest way to do is this. The first one, you can argue, you can get shells for point charges. Think about it. These kind of equipotential surfaces will come due to what? Either due to point charges or due to solid sphere or due to a hollow shell, isn't it? So anything that is round only can create these kind of things or a point charge. So from there, you can guess and say, okay, so this is maybe due to a point charge. So you can argue KQ by R is equal to 60. And interestingly, you'll observe that value, right? So next one is KQ by R, that is 20, is 30. You will see that ratio actually matches everywhere. So if you can do that, that is one way of doing it. Or if you can see there, there's a sequence. You'll observe for this thing, the potential of the shell V into R is constant, which is 6. Check it out. 60 into 0.1, 6. 30 into 0.2, 6. 20 into 0.3, 6. So for all these shells, when you do the product V into R, it comes constant. So even this will give you an idea. P is equal to 6 by R. Doesn't this look like KQ by R? So that means this thing must have been created by a charge KQ. So that is equal to 6. And from there, you can find the field. Or you can always say E is equal to minus dV by dr and differentiate it. That would give you 6 by R square. Same thing. Where R is the distance from the center. So this is the field in the region. It's not constant. It is changing continuously. And what about the direction? Can someone tell me the direction? It should be perpendicular to the equipotential surface. So it should be perpendicular to the shells. But is it inward or outward? You guys remember the statement? In the direction of electric field, potential decreases. In the direction of electric field, the potential decreases. That's what the minus sign says. The negative sign indicates in the direction of field, potential decreases. Now, in this question, look at the potential. This is 60, 30, 20. So as you're going out, potential decreases. The field has to be outward. So the magnitude is 6 by R square and the field is outward. Is this clear, everyone? And what about the second one? The second one is kind of more straightforward. You can clearly see all these are plane. So first thing, it should be perpendicular to this. Which direction? Same story. In the direction of field, potential decreases. So this is 40, 30, 20, 10. So yeah, the field must be in this direction. So it must be like this. And what about the magnitude? You can clearly see here the dV by dr, right? It is uniform. If you just take any two lines, the perpendicular distance between them, this is the perpendicular distance between the parallel lines. This is 30 degrees. This distance is 10 centimeters. That's your opposite side. So that will be 5 centimeters. Since the field is uniform here, because who gives you planes? You get planes because of an infinite sheet. So this is minus dV by dr. And it's uniform. So if you take any two shells, the dV by dr is same. You can't do that here. So in this case, dV by dr is equal to delta V by dr because the field is uniform. The previous case, E is not uniform. The magnitude was changing. What is the potential difference? 10. What is the distance between them? 5 centimeters. Minus indicates direction, so that we know anyway. So that would be 40 minus 30 by 5 centimeter. That is 5 into 10 power minus 2. And that is 10 by 5, 200 Newton per coulomb. That's your answer. Or you can simply set 200 volt per meter. Better. All clear with this? So this is one way of asking. They will give you the surfaces and they'll expect you to figure out the field. Any doubts on this? Let's do the other way around. Let's say we have two infinite planes. This is a XY plane. So this is a sheet. This entire sheet का charge is plus sigma. This entire plane का charge is minus 2 sigma. This is a YZ plane. So two infinite sheets along XY and YZ as shown. Draw the equipotential surfaces. Let's see. So whenever you want to draw equipotential surfaces, right, start the reverse. First find the field. So this plus sigma will give you field which way? It will give you in this direction. How much? Sigma by 2 epsilon. Here you will get sigma by 2 epsilon. It's a positive, right? So the field will be away from the surface. Sigma by 2 epsilon. The green one will attract towards the plate. So that would be 2 sigma by 2 epsilon. Minus indicates direction, which I showed already. So this is 2 sigma by 2 epsilon. 2 sigma by 2 epsilon and 2 sigma by 2 epsilon. So you can clearly see the field lines are actually in this direction. If you see, this is how the field is. And you can clearly see this angle theta, tan theta will be opposite side by hypotenuse, that would be half. Similarly, here also you can clearly see the field. This also makes theta. Here also makes theta. Here also. So you can clearly see. So everywhere the field is making an angle theta like this. Now, if you draw the field lines, first just let's draw the field lines. And this is how it looks. The field lines will look like this. They actually form rhombuses. Remember, this was a positive plate. This was a negative plate. So field lines will go from positive to negative. Like this. These are field lines. This is how the field lines will look. And how is the equipotential surfaces? Equipotential surfaces are perpendicular to the field lines, isn't it? So we have to draw equipotential surfaces perpendicular to this. Equipotential surfaces are perpendicular to E bar. So if you try to draw perpendicular to this, you will see this will be one line. This is another line. These will be parallel, but they will look like this. You getting how are these lines? This is how they would look. These are equipotential planes. That would be the answer. So there will be 4 pictures and you have to select the right one. All clear with this? Yeah, that's the idea about the equipotential surfaces. Everyone clear with the picture? Good, right? You want to do some Rangoli competition. This is useful. Works. Next thing, the dipole. Now, till now, whatever I did, everything was there in gravitation also. Now, dipole is unique. This is not there in gravity. So this is completely different. Now, you want to do Rangoli, right? There's a much better way. Later on, I'll teach you in waves. You can actually have a system where the Rangoli can keep changing every instant without you doing anything. It just automatically by itself. You just need to put some sand or something there and it'll just keep getting patterns. So what is a dipole? The first thing, let's be very clear. Dipole is primarily for chemistry, right? So that is where you encounter it a lot. Physics may, it is just a concept for us. It's a plus and minus, right? So you must have seen in chemistry, right? HCl molecule, dipole moment, CCl4, dipole moment is 0, all this stuff. So what is the end goal of this thing? So what are we trying to do with this? So you need to know where are we going with this so that you'll understand what is the whole picture. We are trying to see what is the interaction between two dipoles. For example, if you have something like OH, so this is a delta plus and delta minus, and if you have another OH, this is a delta minus and delta plus. So basically, this is a hydrogen bonding, isn't it? The OH and OH will interact. You get an hydrogen bonding. So what we are looking at is dipole-dipole interactions. So if you have two dipoles, how do they interact? So that is where we are going to the end. So that is the main picture there. Now, even before jumping into that, so first of all, we need to define what is a dipole, how it works, and then in the end, we will see dipole-dipole interactions. So whatever we are doing, so if you have an idea, right, what is the end point, it becomes more easy to, proceed. So it's more of a mathematical thing rather than as such as physics. So what's a dipole? So a dipole is a combination of a positive and negative equal charges. Is a combination of equal and opposite charges with a distance d between them. Straightforward. So if you have a minus q and if you have a plus q, and if the distance between them is d, we represent this with a vector called p bar, which is the dipole moment, which is q into d. And the direction is taken from minus to plus. I think in chemistry it is taken from plus to minus. So here are arrows from minus to plus. So this is called dipole moment. So the product of the charge into the distance. So it's minus to plus, then it is great. Someone told me it's plus to minus, so but again. Dipole moment. And here d bar is a vector from negative to positive. That's it. So anytime you see something like this, you can call it a dipole. If you have an equal and opposite charges with some distance between them, we call it's a dipole. And why are we so specifically studying about it? Because see, in physics, if you see, right, we really don't care about it. Whatever you want to find, can't I just use Coulomb's law? Find due to Q, find due to minus Q, and finish off the whole question. So we can just use Coulomb's law and get it done. But we see, right, in nature, right, you get a lot of these dipoles keep popping up everywhere. So it's better we define something for a dipole. So that's why we do this thing. So the most common case, right, you see, yeah, you can think of like that. If you look at your HCl, so you have a slight delta plus, you have a slight delta minus. If you have something like CCl4, it forms the tetrahedron. So we have a dipole, we have a dipole, dipole, dipole. So yeah, you encounter all these dipoles there. That's it. That is the first thing. What is a dipole? Q into D. Right? So that is how we use it. A few more examples. So should we have always have equal and opposite charges? Yes, but can we have another configuration? For example, what if you have plus 2Q? And what if you have minus Q? And what if you have minus Q? Let's say it's an equilateral triangle. And if someone asks you, what is the dipole moment of this system? Since the charges are equal and opposite, what we can do this, we can split this into plus Q, minus Q, plus Q, and minus Q. We can treat this as two dipoles. So treat this as one dipole and treat this as one dipole. This angle is 30 and 30. I'm taking an equilateral triangle. So this can be written as (30 and 30). P and P is nothing but Q into A. So the whole system can be written as 2P cos 30 J cap. So remember, it's a vector quantity. So if you have equal and opposite charges in a system, you can just split it into multiple things and you can finish it off. Yeah, you know chemistry, right? Covalent bond, the whole thing doesn't really get transferred every time. Clear with this? In a conductor, yes, but in a non-polar molecules, it doesn't work that way. The electron cloud simply shifts, so we call it partial charge. All clear how to do this thing? Let me give you one more example. You guys tell me what is the dipole moment for this. Suppose if I give you 4 charges on a square, let's say this is plus Q, this is minus 2Q, and let's say this is 4Q, and let's say this is minus 3Q. Can you find the dipole moment of this system, the magnitude and the direction? So you can always split it in any way you want. End of the day, the dipole moment will come same. The only condition is you should have equal and opposite charges. Okay, let's see. So what I can do, I will write this thing as plus Q, minus Q, minus Q. This is minus 3Q, plus 3Q, and plus Q. So I will treat these two as one charges, so plus Q and plus Q. I'll just put some colors. So this will be one dipole moment, which is Q into A. I can treat this minus Q and this plus Q as one dipole moment. That will be another one, which is Q into A. I can treat this minus 3Q and this thing is another dipole moment. This will be 3Q into A. So this is I cap. This is minus I cap. And this is minus J cap. So the dipole moment of this whole system will be 2QA I cap minus QA J cap. Check. You can divide however you want. So end of the day should get the same thing. This is a better way. Don't get the magnitude. Dipole moment is a vector. Keep it in vector form. All clear with this. So first thing, we are just trying to find how to calculate dipole moment. That's it. So this is 41 or 42. What if I have a ring? The right side of the ring has positive charge. The left side of the ring has negative charge. Find the dipole moment of this ring. Dipole moment का symbol is P, okay? So we are using P bar. Q near, you get QAJ cap, right? Please check it out. Remember, once you use the charge, you cannot use the charge again. So once you split it and use it for particular thing, it is gone already. How do you find for this? You have to integrate. You can't get it directly. Try. Maybe a minute or so. Okay, Samya got something. Let's see how to handle this. So consider at an angle theta, take a small slice d theta. So this slice here will have a positive charge, which is a plus lambda r d theta. That's your dq. Same way, if you just extend it backward, you get d theta here. This would be your minus lambda r d theta. So I can treat this thing as one dipole. So we get a dipole, which is dp bar, small dipole, which is dq into the distance, which is 2r. But remember, it's a vector quantity. Vector quantities you cannot integrate directly. You have to resolve into components. So dp bar will be lambda r d theta, that's your charge, into 2r cos theta I cap plus sine theta j cap. And you can clearly see the limits. When theta is 0, you're here. When you go to the topmost point, theta is 90. When you go to the bottommost point, theta is minus 90. You have to cover only half the ring because you're taking two charges at the same time. So when you integrate this delta p bar, that would be 2 lambda r square integral cos theta d theta I cap plus integral sine theta d theta j cap. So minus 90 to plus 90, that becomes 1, and this is minus 90 to plus 90 becomes 0. We get 2 lambda r square I cap. Now what is lambda? Lambda is nothing but charge by length. So this is q by pi r because it's only half of the ring. I think that will be 2 I cap, I guess, no? Sine theta, that will be 4 actually. So this can be written as q into 4r by 5. Right, Samyak. Why can you do that, Ray, Arya? Feeling?
Yeah, kind of. It looks same to center of mass wala derivation.
It doesn't look at all like that. तो ऐसा नहीं बोलना है. Exam में you'll have guts to do that. अभी बोल दोगे, you are comfortable. तो exam में you'll have guts to go and mark it. But what happens, when you don't know what to do, then someone will come and say lambda is equal to lambda not sine theta. Then now listen, this thing actually looks something like this. Point वो नहीं है. If you look at this, when I ask you to find the net dipole moment, look at the formula here. The dipole moment pi is looking like what? Charge qi into di. If you look at the similarity, so the net dipole moment p net looks like sigma qi di. It's a linear function. Doesn't this look like m into r center of mass is equal to sigma mi ri? Mass का place में charge and di का place में ri. It's a linear function, so it works. Right? So that means, what you can do for all the shapes, you can just replace them, the charge at the center of mass. We have done this before. So all this plus, so anyone remembers the center of mass for an half ring? 2r by pi. Now, if you forgot that, then yeah, that's a problem. Similarly, for the negative charge, you can replace this at the center of mass. And what is the distance? Again, 2r by pi. So what's the dipole moment of this system? Q into 4r by pi. That's the distance between, and what is the direction I kept there. And the best part, this thing works for any uniform charge distribution. Right? So you can take a disk. You can take a hemisphere. So you can replace all the charge at the center of mass at the disk. Center mass of a disk is how much? 4r by 3 pi. So solid sphere, the center of mass will be 3r by 8. So you should know the results. The only condition should be it's valid for uniform charge distribution. The distribution is not uniform, your center mass will not be there. So literally it becomes a center mass problem again. So better you integrate. So you can replace the charges at the center of mass and finish it off. This is valid actually, meaning you just have to find the center of mass. That's the only problem. Clear? So saves you time, makes your life easy if you actually realize that. If you give a non-uniform distribution, that means you have to find the center of mass for a non-uniform mass distribution. That becomes a headache. So then you integrate. So what you can do as a homework, give it a try, because you won't be so lucky that every time they'll give you like this. Let's do a simpler version. Let's say lambda is equal to lambda not sine theta. This is the distribution for the whole ring. Radius r. Find the dipole moment of this ring. You can try this as a homework and verify. So as theta is changing, some parts of the ring will be positive, some parts of the ring will be negative. So I'll write the answer. You can verify. Try this and see. So you'll get something like lambda naught pi r square j cap. Clear? So you can give it a try for that. Great. So now we know how to calculate dipole moment. If I give you a system, you know how to find p bar, whether it's for point charges or is it for continuous distribution. And the only condition, you should have equivalent opposite charges. Great. Now the first part is done. The second part. How does this dipole create a field? Like what kind of fields and what kind of potentials does this dipole create? That's the second part. So field and potential due to a dipole. Now, like I said, most of the times dipoles we see in chemistry, and this happens between two atoms, right? So the distance between two atoms, for example, if we take OH, the distance between O and H is much, much smaller compared to distance between two molecules, isn't it? If you have two water molecules moving around, the distance between OH bond is much, much smaller compared to the distance between two water molecules. That means whenever these dipoles interact, right? So they are interacting at a pretty far off distance. So that's a decent approximation. So that means whenever you deal with dipoles, generally we don't want to study anything close by. We want to study when you are very far. Yeah, the dipoles are exactly like magnet on north and south pole, plus and minus. So like I said, Max doesn't care. It looks the same. So if you have a dipole, P bar, but yeah, whatever you're doing now, exact same thing will come again in magnetism. So minus Q plus Q. And let's say this is your dipole moment. So we want to study the field and potential due to this dipole somewhere very far. Let's say some point here. This is angle theta, and this is distance r. And we take r is much, much greater than d. For example, the distance between the dipoles, let's say, is 1 millimeter, and r is maybe 1 meter. So we are talking something 100 times bigger. So this r bar is a vector from the center of the dipole to point A. Right, and theta, now theta ka angle, right? This is how we take the angle. The theta is measured from plus to minus. The orientation is important. So theta is the angle between P bar and R bar. So this would be your R bar. Remember, right? How do you get angle between two vectors? Tail to tail. So theta goes from plus to minus. So that is how you can remember. For example, let's say someone tells you this is a dipole P bar, and they give you some point here A, and they ask you what is the angle between them. So this was your plus and this was your minus. So the angle has to be measured this way. This is theta. Okay with this. So if your dipole is placed in some weird position, sometimes people get confused how to take theta. So that is how you take. All clear with this. So now we are trying to find the field at this point A, at some arbitrary point due to this dipole. So the one condition we have is that distance is much, much bigger. Now see, if the distance is not big, then we have to use Coulomb's law. I'll find the field due to this, I'll find the field due to this, add them vectorially. I'll get all that. And we can do that. Now here we can do a general way of doing it, but there is also a way of approximating. This is important. What I'm teaching you now will again encounter in YDSC, wave optics, later on. Right? So this mathematical approximation, we use it at multiple places. Again, not a big approximation, but let's see. So this is the idea there. So we have the dipole here. This is plus q. So let's call this thing point A. Let's call this thing point B. Let's call this point C. Maybe should I call it something else? So, okay, AC, whatever it is. Right. So what I want to find here. So when I want to find the potential at this point C, it is simply KQ by AC minus KQ by BC. If I can find AC and BC, which I can actually find using cosine rule, and I can figure it out. But we don't want to do all that. Since I know R is much, much greater than D, we can do a beautiful approximation. This is how it works. So listen. So you want to find AC, you want to find BC. So what we do, we extend the central line. And then we say from point A, drop a perpendicular onto this red line. Let's call this thing A dash. And from point B, drop a perpendicular to B. And let's call this B dash. And since the R is much, much greater than D, we can say almost, the distance AC is almost equal to A dash C. And the distance BC is almost equal to B dash C. Now, it looks weird because I drew the picture like this, but the actual picture will look like this, everyone. This is your dipole. You can see that small arrow there. And this is the point C. So if I try to draw like this, you can't even actually tell the difference. They will almost look like pretty close. And this is even smaller. We are talking about 100 times bigger. So if this is 1 centimeter, this is like 1 meter. Are you getting it? So that it's a valid approximation. It works when the distances are very, very large. Just for understanding, I'll exaggerate the figure. So this is A, this is B. So this is how the line was passing through the center. And you decided to drop A dash here, and this was theta, and this distance was D by 2. So this distance would be D by 2 cos theta. Similarly, when you drop a perpendicular here, this is also theta, and this distance is also, yeah, you can drop from A to BC also, it works. When you do an approximation, it really doesn't matter, like it's just an error though. Clear? So I'm just trying to keep everything from the center. Great. Now from center, we know the distances are. So A dash C becomes nothing but R minus D by 2 cos theta. V dash C will be R plus D by 2 cos theta. So what we did was simply, we brought them onto the same line, right? So now A dash and B dash will look like all are in a straight line. So your life becomes little easy. You get this thing. Some people like to do this. They will say, this distance is there, from here directly drop onto this line. But okay, we want, see, we are measuring the distances from the center, so we'll keep it from there. But is this approximation clear? This approximation is valid only because R is much, much greater than D. If that approximation is not there, you can't do this. This is valid for R much, much greater than D. Now, once you got this, it's an approximation. Remember this thing. This we will use extensively again in wave optics. Now, we just have to dump it in the formula. The potential would be KQ by AC, which is R minus D by 2 cos theta, minus KQ by R plus D by 2 cos theta. Solve this. This would be KQ, multiply, you end up with D cos theta by denominator will be R square minus D square by 4 cos square theta. You can neglect this term here, since r is much greater than d. Then you get v is equal to k into qd cos theta by r square. And qd is nothing but your dipole moment, which is kp cos theta by r square. This is the potential at a point due to the dipole, where r is the distance from the center and theta is the angle. We'll put it in a more usable form later on, but that's how your derivation goes. And now from potential, we need to find the field. Now be careful here. Here all the things are measured in angles and r. So this is actually polar coordinates. Now, if you remember in Cartesian coordinates, whenever I ask you to find the vector, this is what we used to do. We used to say the vector is dx I cap and dy j cap. But in polar coordinates, if you guys remember, in polar coordinates, the world will look like concentric circles. Here, the vectors will be in this direction. We'll have dr, r cap, and this direction will be r d theta, theta cap. So if someone asks you to write a vector here, dr bar, this would be dx I cap, dy j cap. This is in polar coordinates. We had this discussion in circular motion. Here, if you want to write a vector dr bar, this is dr r cap, that's your radial direction, plus r d theta. You don't need to know this, just an idea there. So r cap means radial direction away from the center. Theta cap means tangential direction. R d theta is a small vector in the tangent. And when you wrote the field here, what did you do? You wrote this thing as minus dou v by dou x I cap minus dou v by dou y j cap. That's your partial differentiation in Cartesian coordinates. In polar coordinates, this will become minus dou v by dou r cap minus dou v by r dou theta, theta cap. That's your partial differentiation in polar coordinates. So in place of dx, you're keeping dr. In place of dy, you're putting r d theta. You need not know this thing. Getting it? I'm just showing it. It's not important. The final result is more important. And I don't think even at an advanced level, they will try to poke this or mess with this thing. So when you differentiate this voltage now here, when you do dou v by dou r, you end up with k p cos theta. That 1 by r square will become 2 kp cos theta by r cube, r cap, plus when you do dou v by dou theta, cos theta becomes minus sine theta, minus or minus becomes plus kp sine theta by r cap, theta cap. This would be the field, and this would be the potential. And if you observe, you got everything in terms of r and theta. Have a look at this. Let me put this in a usable form. I'll just brief it up. There. So now, due to that small dipole, we could find the field and potential somewhere very far. Why are you obsessed about somewhere very far? Because when you see the dipoles, when they interact, the distance between oxygen and hydrogen is so small compared to the molecule and molecule. So we can say, yeah, it works. So like I said, remember the story is what? We are trying to find dipole-dipole interactions. So for a dipole and dipole to interact, we need to know what is the field due to one dipole, first of all. So we need to know what is a dipole. We need to know what is the field due to a dipole. And then we are going to see in that field, if you bring one more dipole, how they will interact. So that's how we are building this whole thing. Any doubts on this page? So the first thing was the approximation. Since they're very far, I can do this approximation, which is reasonable. Once I did this approximation, I got AC and BC as r minus d by 2 cos theta, r plus d by 2 cos theta. I dumped it in the potential, simplified, I got the potential. From potential to field, I need to differentiate it. But here, things are changing in terms of r and theta. So I can't use a Cartesian differentiation, I have to use a polar coordinate differentiation. And this, you have a bit of an idea, which we encountered in circular motion. So yeah, we did it. Now let's put it. So if you want, you can copy this down. So if you have a dipole, P bar, if you're taking a point somewhere here, so the field will be like this, 2 kp cos theta by r cube, r cap. So this is the field away from the center. This is kp sine theta by r cube theta cap. This is the tangential direction. And remember the tangential direction, plus to minus. That's how we should rotate. So the field at that point would be, if you want the magnitude, you can square them and add them. You end up with kp by r cube. That will be 4 cos square theta plus this thing. So that's 3 cos square theta plus 1. Again, not that a big deal. You know, the vector component, you can always get the magnitude. And the potential will be kp cos theta by r square. We can even write this in a vector form. Now, every time you won't be so lucky, you know, they'll give you the distances and all. Sometimes they'll give you p bar and r bar. So how can we put this in a vector form? So we'll talk about that a little bit later. First, let's get used to this. We will write the vector form also later on. I'll write it down. We'll prove it later on. So EP bar is nothing but k by r cube 3 times p bar dot r cap into r cap minus p bar. That's a vector form. If someone gives you r bar and p bar in 3-dimensional, they'll say p bar is I plus j plus k and r bar is 2y minus 3j plus 4k, and they'll ask you find the field at a point. It's difficult to figure out the angles and everything. You can, but this is your vector form. Quite a useful thing. Then the two important cases. This is a mains and CET they ask a lot. Case 1, if you take a point P along the dipole, this is called axial line. Field along the axial line, that's what they will say. So at this point, the field will be kp 2kp by r cube. The theta is basically 0. So if you go along a dipole, the field will be away from this. Case 2, this is also called as equatorial line or perpendicular bisector, whatever you want to call. This is a case when theta is 90 degrees. Means if you take a dipole and if you go straight on the perpendicular bisector, so the field here will be, the 2 will be missing. You will get kp by r cube. The field will be opposite to the dipole. These two are very standard questions at mains and bits like this. Clear with this? How to write this vector form? Let's see that. So this component was 2kp cos theta by r cube, r cap. This was kp sine theta by r cube, theta cap. So first let's define how these vectors are basically. So this was your p bar. This was your r bar. And this was your angle theta. So I can resolve this into components. This is p cos theta. And this is p sine theta. And this p cos theta can be written as, so look at the direction there. This is p cos theta r cap. Isn't that the vector? So the dipole moment p cos theta in the direction of r cap is this. And what is p cos theta r cap? This is p bar dot r cap into r cap. So this is your p parallel vector. So this is a vector along the r bar. I hope you guys remember this. This thing comes from vector component. You learned it in vectors. A bar dot b bar is mod a mod b cos theta. So here you're trying to find the vector between p bar and r cap. So P bar dot R cap will be P, that is 1 in cos theta, so which is P cos theta. So P cos theta can be written as P bar dot R cap. That was 1. Similarly, if you guys remember, a vector P bar can be written as P parallel vector plus P perpendicular vector. The P perpendicular can be written as the parallel vector P bar minus P parallel. But we know the parallel vector is nothing but P cos theta R cap. That is nothing but P cap minus P cos theta just now we derived P bar dot R cap into R cap. That's basically P perpendicular is nothing but P sine theta. That is this guy. So this guy can be written as P bar minus P bar dot R cap into R cap with an overall minus sign because it's pointing in the other direction. Right? That's your P perpendicular basically. So you can write P cos theta as this, and you can write P sine theta as this. Now take these vectors, dump it in this, and this can be written as 2k P cos theta becomes P bar dot R cap into R cap by R cube. And sine theta becomes that perpendicular vector. I'll name them as P parallel and P perpendicular. But this vector is opposite to the perpendicular, so this can be written as minus k P perpendicular theta cap by R cube. So if you add this, two k P bar dot R cap by R cube minus k P perpendicular is nothing but P bar minus P bar dot R cap by R cube. Arrange the terms, you will end up with k by R cube 3 times P bar dot R cap into R cap minus P bar. That's your the vector form. Again, not really important. At a mains and bits, I don't think they'll ask anything like this at all. Advanced, there is a possibility. And you might think like, oh, what is all this perpendicular vector and all? This is not the first time. You guys forgot. We did this thing, where first time? We did this in vectors. And you know which question is that? The equation, yaad hai? You have seen something weird like this before. The relation between incident angle, reflected ray, and the normal vector. Look at that. R cap is I cap minus 2 dot I cap, N cap, and N cap, all that stuff. We have done this kind of stuff before. And this thing, right, is all this thing only, component of one vector in the direction of another vector. If you guys remember this question, look at this question here. Find the perpendicular component of A bar along B bar. Everyone knows how to find the vector component, but I want the perpendicular component. And this is the logic we said. We said a vector can be divided into A perpendicular and A parallel. I already know how to find A parallel. So A perpendicular will be A minus A parallel. And then we finished it. That was the whole logic there. So it's a good technique, but I think you should try to derive this on your own again. It helps. See, that is how you learn. It might look weird for the first time, but if you do it on your own once or twice, you will think this is normal. That helps a lot. But this is your vector form. Clear with this? Take a break. Come back by 9:45. We'll continue from here. Let's see a question. Comes on everyone. So let's say we have two charges here, plus Q minus Q. The distance is D. Let's say Q ka value is 2 into 10 power minus 3 coulombs. Small d is, let's say, 3 millimeters. There's a point here at a distance of root 3 comma 3 meters. Find the field and potential at point A. This is simply formula substitution. You just need to put the values there. So first of all, let's find the dipole. Dipole P is Q into D. That would be 6 into 10 power minus 6. Great. Next thing, we need to get the angle. So this is the distance R, which is how much? Root over 3 square plus 3 square. That's root 12. And how do you get the angle? Remember, this is angle theta. It's not the other one. This is theta. And what is tan theta here? Opposite side is root 3 by 3. This is 30 degrees. One of the most common mistake, people think theta is 60. So be careful with that. Because theta is measured from positive to negative. Yeah, then you're done. You will get whatever you want. So you want the potential V is equal to 2 kp cos theta by r square. You know everything there. You want the field will have two components. One is this component, which is 2 kp cos theta by r square. The other component, remember, it should be in the direction of theta. That should be in this direction. Kp sine theta by r cube. Yeah, and then you want I cap j cap, you can do that also. If that is 60, right? So this is 60. So this is 30 and this is 60. So the field at that point will be 2 kp cos theta by r cube cos 60 plus kp sin theta r cube cos 30 I cap. So you can resolve these things into I cap and j cap, and plus 2 kp cos theta by r cube sin 60 kp sin theta by r cube sin 30 j cap. So that's your field in terms of I and j. Remember, field is a vector quantity, so you have to give in terms of vector form. All clear with this? Easy, straightforward. So once you know the formulas, it is just a matter of substituting. Most people don't remember the formulas, so do remember this page clearly. If you can remember this main thing, it's sufficient. The field and the potential, you can handle most of the questions. Let's see one more. So we have a dipole along the x-axis at the origin. Find the locus of all the points where the field is along y-axis. So due to this dipole, there is a field at every point. There are some points where the field is only in the y-axis, positive y or negative y. If you join all these points, you get a locus, some curve. So find the locus of the points where the electric field is only in the y direction. Let's see how we'll do that. Hope the question is clear. This dipole is generating field at different points. Advait, your cam is completely blank, right? Can't see you. It's completely dark. Do something about it.
Yes.
Any answers? So let's start like this. Let the point be x comma y. Let's take some random point somewhere here. Let this be angle theta. So the field here will be 2 kp cos theta by r cube. And this field will be kp sin theta by r cube. And now you're telling me the resultant of these two vectors is in the vertical direction, meaning indirectly you're telling the horizontal components are canceling. So if that is theta, and this is 90 minus theta. Since E bar is along y-axis, that means the horizontal components cancel out. So that would be 2 kp cos theta by r cube ka cos theta must be kp sin theta by r cube ka cos 90 minus theta. That's another sin theta. You can clearly see you get tan square theta is equal to 2. So if you take this coordinate as x comma y, tan theta is nothing but y by x. So we get tan theta is plus or minus root 2. So this is nothing but y by x is equal to plus or minus root 2. We actually get two straight lines. So y is equal to plus or minus root 2x. So if you draw two straight lines like this, on these two straight lines, the field is always in y-axis. All clear what we did? So y is equal to plus or minus root 2x is a pair of straight lines. The field along these lines is in y-axis. And if you see, right, it is always about the formula. If you know your formula, you can get everything, the components, this you can play around. Yeah.
Sir, but like near the dipole, this won't be valid, right?
Why?
Sir, because the approximation will fail.
What approximation here? So we are assuming the points are far off.
Okay,
Don't
so
get too
the
close.
initial things will be dotted.
Yeah. Don't get too close. What about it at origin? What about the origin? So yeah, we don't get close to the origin, Hari. That is the whole point. The moment you say dipole, we are always talking about far off points. If you get close to the origin, then don't everything fails, right? The formula itself is wrong, so don't use it. Clear? And because see, if it is close, they won't call it a dipole anymore. They'll simply say there are two charges, find the field there. All clear with this? So there, now you know how to calculate the dipole. So now you know what is a dipole, you know how to calculate dipole moment. Now you also know how to calculate field and potential due to a dipole. The next part, how does a dipole behave in a field? So if you take a dipole and put it in a uniform electric field, please go through this entire dipole thing and resolve the questions. It's not tough, but people generally find it, little weird and all because it is a little difficult to visualize. It's, it's not any, frankly speaking, it is not exactly a physics ka thing. You could do plus q minus q with Coulomb's law and stuff, but because we see dipoles, we wanted to study about them. We created this whole story like the dipoles. So what happens if you have a dipole? So if you take a dipole p bar, and if you put this in a uniform field, let's say the field is e bar, making an angle theta. Now, if you just draw the picture here, we know the dipole is nothing but a plus q charge and a minus q charge. So if you put it in a uniform field, you will experience a force EQ and a force backward EQ. So you can clearly see this is a couple. The forces are equal and opposite. And if this is angle theta, this perpendicular distance will be, so this distance is half of the distance d by 2. The perpendicular distance is d by 2 sine theta. So a dipole will have a couple. So the torque is given by Q E d by 2 sine theta 2 times because there are two charges. This is the torque due to the dipole. So this will be Q D E sine theta. But I know QD is nothing but P. This is PE sine theta. And we know PE sine theta is nothing but P cross E. There, that's the vector form of torque. If you know the dipole vector, if you know the field vector, you'll get a torque which is P cross E. And for small theta, suppose if you disturb it by small theta, then torque becomes PE sine theta is equal to minus I alpha. So we get alpha is equal to minus PE by I theta. This is an angular SHM. So the dipole will actually oscillate. You can bring even your SHM. Where I is the moment of inertia of the dipole. 2 pi root over I by PE. So they will give you the mass of the dipoles and all, so you can figure it out. There, you can bring your SHM also. And now if you actually think about this, you have seen this thing before. The question, yeah, we said this was a oscillatory motion. So if you disturb this for small theta, this is also an SHM, isn't it? This was actually a dipole. If you see the upper part is positive, lower part is negative. This was a dipole. right? So we didn't know what was a dipole before, but we did actually solve something similar. All clear with this? So if you put a dipole in a uniform electric field, it will try to rotate and it will try to become parallel to E bar. It will try to align in the direction of the electric field. All clear with this? Then now if you're rotating a dipole, that means you can also have energy. So if this is your dipole P bar, and let's say this is your E bar, and let's say you rotate this dipole by d theta. Let's rotate it slowly. Then the work done by external force will be integral torque d theta, which would be Pe sine theta d theta. Limits will go from theta 1 to theta 2. This goes to minus Pe cos theta 2 minus cos theta 1. This will be your change in potential energy because there's no change in kinetic energy. So u theta 2 minus u theta 1. And we know whenever you define potential energy, we always need a reference. So we choose theta 1 is equal to 90 as reference. That means when u at 90 degrees is 0, you end up with u of theta is minus Pe cos theta. And what is this? So the potential energy u is given by minus P bar dot E bar. There you got your dot product and your vector cross product both in the same thing. So the potential energy u bar, u is a scalar, is given by minus P bar dot E bar. So if I do the cross product, I will get the torque. If I do the dot product, I'll get the energy. This is the potential energy of a dipole. Remember, this is valid only for uniform field. The examples in the exam, they would ask something like this. They will say there is a dipole P bar and there is a field E bar. Initially, it is 60 degrees. They would say something like this. Find the work done to rotate the dipole 30 degrees towards E bar. That means you're trying to rotate the dipole will become like this. This will become minus P bar. This will become E bar and this angle will become 30 degrees. Same thing. So work done by external is equal to change in potential energy. So that would be minus Pe final will be cos 30 minus of minus the U final minus U initial. U final is minus Pe cos 30. U initial is minus Pe cos 60. Just be careful with the signs. Substitute there, you get the answer. That's a CET type question. You do get those kind of questions in CET. And if the mains paper is too easy, maybe you'll get one or two like that. Clear with this? So just to give a little more context, so this is what we did. If your field E bar is this way, when you took the dipole perpendicular, theta 90 degrees, torque is maximum. Basically, this is your thing here, extreme kind of thing, and U is 0. If your dipole P and D are parallel, theta is 0. This is your stable equilibrium. This is where you get SHM. Torque is 0 and potential energy is minimum minus P. Suppose if you put a dipole opposite to this, theta is 180. This is an unstable equilibrium. You can keep it at rest, but if you disturb slightly, the whole thing will turn. Torque is 0, but U is plus C. Clear with this? Any doubts on this? Great. Let's see a question on this. So we know how it behaves in a non-uniform field. What if you put this in presence of a non-uniform charge? Listen to this thing. A dipole is placed in presence of a point charge. So point charge ka field is non-uniform. Let's focus, everyone. Others, do keep your cams on. Why should I keep reminding you guys to keep the cams on? Like, why are you guys behaving like kindergarten kids? Which of the following are possible? So these are the options. Torque 0, force 0, torque 0, force not 0, torque not 0, force 0, torque not 0, force not 0. So among these four options, meaning you can put the dipole however you want. The charge is there fixed. You can arrange the dipole however you want. And which of these four cases is possible? Clear, Vanshika? Question is clear? Let's give it a try, everyone. Arya, keep your cam on. What do you guys think is the answer? So the question was something like this. So you have a plus Q charge. And you're saying I'm going to keep the dipole anywhere. P bar, P bar. You can keep it however you want. Then which of the following is possible? Right, Samyak. Anyone else? Ne param. See, when you take the charge Q, how are the field lines? If you see the field lines, they're radial. Now think of a possibility, way you can get torque 0. First of all, you can't use torque is equal to P cross E because the field is not uniform. Torque is equal to P cross E is not valid. Right? So, okay. But think of like this. If I take a dipole and place it along the field lines, I know the field is not uniform, but if you see if P bar is along E bar, along the field lines, this is what you will see. So this is plus Q, this is minus Q. Here the field will be something E plus DE, and here the field will be E. In this scenario, you can clearly see force is not 0, but torque is 0. Because the forces will pass through the center of the dipole, isn't it? The forces are equal and opposite. So is that making sense? So you can create a case where the torque is 0, but force is not 0. right? And you can also create a case where torque is not zero, force is also not zero. That is also sensible. But you can never create a case where force is zero. Think about this. Now, I'll tell you in two different ways. You see whichever you like. Now, if you want to get force zero, you have to get the magnitude equal and you have to get the direction opposite, right? If you want to get the direction opposite, you have to keep the dipole along the field line. But then the magnitude won't be equal. If you want the same magnitude, then I have to keep the dipole on two different field lines like this at same distance r and r. Then I will get the same magnitude. This will be EQ and this will be EQ, but the direction won't be opposite. You're getting the problem there. So there is no possibility you can have a zero force anywhere. But there is a better way to explain this. Let's go reverse. Can a dipole create a null point? Is there any place where you have a null point? It's plus q and minus q. You don't have a null point. A dipole does not have a null point, not in the center also. Center may they add up. Does not have a null point. Therefore, the force on the charge is never zero. So if you take this charge and put no matter where you are, the dipole can never create a zero force. The force on charge is never zero. And by Newton's third law, if the force on the charge is not zero, then the force on the dipole is not zero. That's how you can argue and finish off much. You get better clarity there. If the dipole cannot create a zero force on the charge cannot create a zero force on the dipole. The force on the dipole is also not zero. So the answer for this thing is you can have torque zero, but you cannot have force zero. So force zero options are wrong. B and D. Are you clear with this? So that's how you can figure it out there. Everyone should focus on the class. Please be in the class. You have something important, you can wait till the end of the class, then you can go and discuss. Any doubts on this? All clear with this? Please focus. All these things are important. You know, now you guys are talking and chilling out and relaxed. Next year, this time you'll be crying. And then you'll be calling and complaining, sir, मुझे CET नहीं आ रहा है, मुझे bits नहीं आ रहा है, mains नहीं आ रहा है. What option do I have in my hand? Please tell me, sir, what should I do? I will do anything. I will study like every day 14 hours. I will study 15 hours. Point नहीं है, मतलब at that point, right, there is nothing you can do. No matter how many hours you'll study, no matter how much sincere you'll become, the time has passed out. Right? I know, meaning see, difficult studying and all. See, studying is never supposed to be easy. Maybe you guys thought, you know, पढ़ने क्या है? पढ़ना बहुत difficult है. Sitting and focusing is very difficult. And that's what will make you different from others. If every idiot can sit and study, right? I can show you intelligent, super IQ people, huh? But these people can't sit at one place and can't focus. Right? I can show you people who are really hardworking, right? But they go to the exam and they panic. They don't understand why they're studying. They don't know what they're doing. They have all misconceptions about exams. Why are you guys becoming like that? Like, you still have an year of time, right? You still have around, like, not once a year. Next Jan is your exam. And this will matter a lot. Going to a good college will matter a lot. Because when you go to the good college, again, I'm not saying college will teach you something, blah, blah, blah. When you go to a good college, you will meet good people. As simple as that. Your peer group will be better. Think about it. You join NIT or BITS or IIT. The people who have come to that college must have studied hard, must have worked hard. These kids are ambitious. They really want to achieve something in life. Don't you want to have such kind of friends? And do you think those kind of people will join in some local Mumbai colleges? Some Dabba college and some Chembur ka, some Don Bosco Engineering College and stuff. VJTI is a good college, but cutoffs are high. BITS में भी आपको 185 आना चाहिए VJTI के लिए. College of Engineering Pune. There are really good colleges in Mumbai also. Cutoffs are high. So you guys need to decide this thing, it is supposed to be tough. If someone thought it is easy, ho jayega and all, I think you are still living in an illusion. You still have time to do this thing, but I don't see some of you taking this seriously. Right? I gave you the tracker. I don't know how many of you actually started feeling, with the Don Bosco naam acha lagta hai, so I just take up every time. Right? It looks like Don Bosco, मतलब वो college में पढ़ेंगे तो दुबई में Don बनेंगे, तो something of that sort. I used to, tease people like that. So, और कुछ नहीं, I have no idea where is that college also properly. That poor guy will actually blame me if no one joins there. So think about it. I'm seeing your seniors, right? Yeah, things are really not that good. The kids are saying like, sir, I will study now. मतलब now अभी study करने से क्या होगा? Two people have called me and said, sir, we want to repeat. I told them outright, I told the parents, if this kids repeat, right, you're wasting 1 year of your time and your money, वो करेंगे नहीं. The parent is like, sir, like, the kid is asking for a chance. They had a chance. There is no going back. You guys are not understanding. You guys are not kids. School nahi hai ye. There is no turning back. Time is moving on. You will keep getting old. You will never become younger again. There is no going back and saying, oh, I will redo it. Right? Though I tell them that only. If the kid is getting a very good rank and maybe for some reason you want to improve, repetition is not an option only. So the kid was insisting, नहीं sir, मैं इस बार करके दिखाऊंगा and all. I said, ठीक है. May 24th को बिट्स एग्जाम है. Right? अभी से almost you have this discussion we had on May, April 15th. So roughly you have 35 days, right? You have 35 days for bits 2. Bits 1 he scored 165 out of 390. कुछ नहीं मिलेगा. कुछ भी नहीं मिलेगा. Getting it? I said, do one thing. Next 35 days, every day study for 10 to 12 hours. Every day send me a report. Bits में 165 है ना, उसको तो 200, 220, 200 plus cross करके मुझे बता. You cross me 200, 220. 35 days में if you study 10 to 12 hours, इतना तो improvement आ ही जाएगा. You do this much, right? If you cross 220, then I will convince your parents. I will tell them it is okay. You can drop for one more year. Am I saying something reasonable? You have 35 days to prove you're actually sincere. He's like, no, sir, I will do everything from scratch. I will need more time. I said, what are you planning to do next 35 days? You know what he's planning to do? Kuch nahi. He's just going to relax now. Now he will calm down. He will think like, since I'm repeating anyway, now I can do little less work. I can relax more. After the everything from June onwards, I'll become serious. You have an opportunity right in front of you. 35 days, you don't want to study, but you want to do it later. I told the parents clearly, this guy is just bluffing you guys. Right? He will never become serious about it. Best thing, join him some local, जो भी college मिलते उसमें डाल दीजिए. Right? It's just a waste of time. But if you still think, this is my opinion, okay? You guys think like, no, मेरा बच्चा कर लेगा and all, your own kid, your money, your time, please do whatever you want. But that is the truth. The father understood. Mother was a little emotional. And then father said, no going, nothing. चुपचाप bits का पढ़ो. मतलब simple ना. I gave you a task. Prove me, right? 35 days, improve 40 marks. How difficult is that? Yeah, that guy was not ready. Like, yeah, I can clearly see. Just a waste of time. So you guys are not that kind of idiots. Getting it? You guys are much better than that. So out of, everyone says, 12 lakh people, bullshit 12 lakh people. In that 12 lakh, there are only like 50,000 people who are actually studying and who are actually focusing. So be among that 50,000 people. Trust me, things will take care of it. There are many people who are studying but sabotaging their own progress. Right? They can't even look at beyond, after 1 month, where a subject case hoga, they can't even think. They're only bothered about this Sunday exam ka marks. As simple as that. Think little long term, you will beat many people. In IIT, when I was there with my friends, I have seen people. These people are intelligent, smart. मतलब वो लोग genius बोलते हैं ना. I have seen those kind of people. You guys really don't know what is a genius. And these geniuses also used to work hard like mad. And just to give an example, there was a guy in one of my batch, right? मेरा close friend था वो. And this guy liked a girl who is an MBBS, right? I think I told you this thing. She was in third year or something, and she's having a problem with a certain subject. This guy studied MBBS ka that particular subject year 1, year 2, year 3, explained it to that girl, and made her pass in that course. He did this thing in a span of 22 days. And that guy is a pro in biology. Getting it, he is better than that girl. Now they are married, they have a kid and everything, right? So think about it. I said, खुद का subject नहीं आते हमको, and this guy is studying some random subject like bio. So like, just telling you, meaning I'll tell you, there are people like that, like insane of talent. They have insane amount of talent, but they put insane amount of hard work also. People don't realize that. सबको लगता है talent से हो जाएगा. Bullshit होता है talent से. So please take things seriously. और कुछ नहीं, I'm telling you, because हो गया उनका. Most of your seniors, right? If you see, when I started the whole advanced का revision program, when I started mains का revision program, out of 60 people, 48 people used to attend. After mains got over, advanced program started. Out of 60 people, 28 people attended. Right now, 16 people are coming. So there, your competition is going off. Anyway, so let's see. Think about what I said. All you need to do, all I'm asking, I'm not asking you to sacrifice or do anything. Start putting work sincerely, do it regularly. I think that should take care of it. And think little long term. Anyway, studying for the Sunday exam is not improving your Sunday ka marks anyways, right? You're getting that same old hopeless marks only. So then if that is the same case, then why are you focusing on it? Focus on the subject, improve your subject, think little long term. So we got a ring here, plus Q and radius R. Yeah, don't think I'm angry on you or something. Huh? This is how, I don't know what to call this thing also. I think it's called helplessness or something. You're just standing there and you couldn't do anything about it. That is how it feels. And the kid calls and says, "Mujhe kya karna chahiye?" And I have no answer. And the kid is waiting, I'll say something so that the problems will be solved. And nothing, and there is nothing I can say. It is like, it's like you're standing there and maybe your friend or your someone in front of you is just drowning and getting away. The river is just taking them away. And you can't do anything. You're just standing there and watching. It hurts. It feels bad. And there's nothing you can do. And I'm seeing this every day. I'm getting calls day in, day out. It's tiring. And ऊपर से your juniors are there. They're more idiots. They're asking any bullshit questions they're asking. Told you, na, there is a guy, 2y plus j, वो 3 करके, he's fighting like why it is not 3. Right? And वो भी ठीक था. H cap, J cap, they don't know, I can understand. Some guy wrote like this thing. I wrote sine 30 plus sine square 30, sine cube 30, and so on by, I think I told you this also, tan 30 by tan square 30, tan cube 30 GP tha. This guy writes it as sine 30 by tan 30 plus sine square 30 by tan square 30, sine cube by tan cube 30. And he's like, ये ऐसा क्यों नहीं होता है? ऐसे like, अरे यार मैं करूँ क्या exactly? This is how your new 11th का kids are. They don't know height of an equilateral triangle. They don't know centroid well divided in 2:1 ratio. They don't know for a square, half of the diagonal is a by root 2. That is another kind of problems I'm facing. So normally some are always like that. Juniors are always bad only. It happens. It takes time. They'll improve, but they just have to understand. They have to just go and revise and it will be done. These people are lazy. They don't revise. They think asking a question in the class means they did the work. Done. उसके बाद हम कुछ नहीं करेंगे. Teacher will do everything. I think school में that's how it used to work, I guess. The one who asked a doubt is a good student. That's it. Not the guy who thought about the doubt, who tried, getting an answer for the doubt. That hard work was never, what do we call it? Rewarded. The one who shouts more and more questions in the class is the intelligent guy in the class. Good for nothing. I used to scold them right and left in the class. I said, what kind of bullshit is this? In the advanced exam, who is going to come and tell you your doubts? Anyways, so we got a dipole here. Let's keep the dipole here. So we got a dipole P bar. Let's finish off with this. We are almost done. That's it. I'm not angry or anything like this. I'm just scared. So put some effort. You are, it's not really that difficult. People make it. मैं बोल रहा हूँ ना इस बार the kid who scored 183 out of 360 in the mains one, they ended up at a rank of like 10,000, 11,000 mains में. It might look big, but understand one thing. If you got 11,000 rank, in this 11,000, almost 8 to 9,000 people will go to IITs. Right? ये सब लोग आईटी भी जाएंगे तो सीट्स तो बच गए हैं ना एक्चुअली you get pretty good NITs. You have a good shot at advance. And if you're a girl student, you have 20% reservation. I keep telling you this. 11,000 rank is as good as getting a 6 to 7,000 rank as a boy. अभी इतना unfair advantage है तो use it. Right? So you should definitely take full advantage of it. And boys, so we are just useless creatures. तो हम कुछ नहीं कर सकते. तो we are there. Can't do anything about it. So we just have to think it is unfair and we have to keep moving. See, life is unfair. There's nothing you can do about it. Right. So I know how it feels. So I'm also a boy, I'm also a general category. So can't do anything about it. See, it is like this. You can't go to a lion and say, see, lion, I won't eat you, so you don't eat me. Right? Let's be fair to each other. The lion doesn't give a shit about you. Getting it? That is how it is. So you need to get used to being, the life is unfair. It is unfair. So you have to get used to that fact. Anyway, so we got a ring here on the charge. We kept a R root 3 mein. There is a dipole. Find the torque and the force on the dipole. Let's finish off last minute for that day. Next class, I think I'll take another 20-25 minutes. We'll finish off this chapter. We'll start off with gravitation. Find the torque and force on the dipole. The next part is dipole-dipole interaction. That's the last thing. ये juniors का doubt. Sir, HC Verma last year का book color is different. This year का book color is different. Is it? Should I buy the new one, the old one? I said, ठीक है. Can you send the color of the book? No, this happens every year to me. Don't worry. It's normal. April is the worst year in my life, in the entire year. Because I'm in extremes. For your seniors, I teach them high level advanced, weird problems. For your juniors, I teach them 1+1 is 2. So it's like I'm at two extremes. I go mad, and upar se I keep getting calls and people cry. So it's like a trauma. I think after May 15th, I'll become normal again. So it's like, and you should be careful. Huh? The day I stop scolding you, meaning I gave up on you. That is how it always goes. Think about it. Why does someone keep telling you, shouting at you? Because they care about you. When someone has given up on you, they will say, ठीक है, जो करने कर लो. Mom says that, na? You will say, Mama, मुझे बाहर जाना है. No, मत जाओ, मत जाओ. You'll keep fighting, fighting, fighting. Mom gives up and says, जो करने कर ले. Mom has given up. She'll stop fighting with you. And then you will stop, right? Then you'll say, ठीक है. Mom said, do whatever you want, matlab, I should not go. You will understand that That's a subtle hint. You go out and see, I'll show you what it is. No worries. Let's get this thing. How do we get it? The torque is the easiest part. So what is the electric field here? Yeah, the formula E is equal to KQX by R square plus X square whole power 3/2. And torque is equal to P cross E, which is P E sine theta. Theta is given, P is given, X is given. Dump it, you'll get the answer. What about the force though? And remember, this is a non-uniform field, right? And the dipole is very small, very small dipole. So yeah, dipoles are small only, but this is a non-uniform field. So there is a force. It's a uniform field, the force would have been 0. So what we do, right? See, you can't get the force directly by this thing. But you can get from something here. What is potential energy? Minus P bar dot E bar. So potential energy is minus P E, which is K Q X by R square plus X square whole power 3/2 cos theta. This is your potential energy. And we know from work per energy, force is minus du by dr. In this case, minus du by dx. Yeah? So you can get potential energy and differentiate it. And you can differentiate this. But the only problem with this will give you the force only in the radial direction. So when you do du by dx, this will only give you the force in the I cap. There is a force in the vertical component which we cannot find. So this will give you only fx. Fy cannot be calculated. So they won't ask you that. Mostly they'll ask you find the force along the axis. Force on the dipole along the axis. So they will keep it simple that way. There are ways to find it, but it goes way beyond. You have to use polar coordinates and all that stuff. You won't have it. You will not calculate it. It goes way beyond our portion. We don't need it. Clear this? Yeah, that's how we can get the force. Get the potential energy and differentiate it, and you're great. Clear this? So then now it looks easy, but you have to get an idea. Okay, so that's the one thing there. So next class when we catch up, the last thing that we're left is dipole-dipole interaction. So that's your last thing. So which we'll do it in the next class Tuesday, and that might take another 20-25 minutes, and then we'll start off with gravitation. So please make sure to go through the entire notes and start solving your electrostatics. If your electrostatics is good, gravitation will go really smooth for you. Gravitation is not a big topic. Maximum we'll finish off in 3 to 4 classes. I think 3 classes we will wrap it up. So first 1 or 2 classes we will just revise all these formulas again, and then we will spend more time on satellites. I think 3 classes we should be able to finish it off. Right? So because if your electro is good, like I keep saying, your gravity goes fine. So, and remember, entire electromagnetism is 33% weightage. So that's your 1/3 of physics. Okay, with that we'll wrap up for the day. And do remember, there's a test online till tomorrow, so make sure to give it. It's a full syllabus ka test, and don't worry about like, oh sir, I didn't prepare. No issues. Write the test. If you mess up the test, go and resolve. Now you will learn. Writing the test is a revision. Are you getting it? Every test is not to score. Some tests are to learn. So think of it that way. It'll help you.